right, welcome to your first Math 111 video. Please remember as you go through this, yes, take notes, pause the video often, work the problems as as you feel you're able. Like if you want to stop and try it on your own and then see how you did, that would be great. And then please remember when you're done, stop the video, look back through the notes, make questions, write down the questions you still have, the things that are not clear, and please post those to the forum for the notes so that we can start addressing any conceptual questions that you have. All right. So we're starting into the chapter 6 and chapter 7 units. Chapter 6 is dealing not with discrete random variables, which is what we did in chapter 5. We had those probability distributions. What is the likelihood of one person, two person, three people, whatever, having a certain characteristic? In chapter 6, we're going to talk about those continuous random variables. So again, remember, we can take on infinitely smaller details here, number of ounces, number of inches to something. We can keep whittling those down to smaller and smaller and smaller increments. So because of that, probability distributions are not histograms, they are smooth curves. Okay, so taking a look here at our first example. A local factory produces a bolt whose length has a population mean of 15 centimeters and a population standard deviation of 3 centimeters. Consider a normal probability distribution that represents the probability distribution. Okay, so what is a normal probability distribution? Okay, so first let me define that. This is a bell-shaped curve that is perfectly symmetrical about the mean. And we will still use the symbol mu to represent the mean. Okay, so it is perfectly symmetrical. Now again, this is in like a perfect world. In reality, nothing is perfectly bell-shaped, but statistically speaking, that is how it is represented. Okay, the notation for that would be x, your random variable, whatever that is. So in this case, the length of a bolt would be x, is distributed, so our little tilde or little squiggly line, capital N for normally, with a mean of whatever that happens to be, and a standard deviation of whatever the standard deviation happens to be. Okay, in this example, we would write this as x. Again, the length of the bolt is normally distributed with a mean of 15 centimeters and a standard deviation of 3 centimeters. Okay, that's how you would describe that distribution, again, in a fairly simple and concise manner. Okay, so now what does it mean to graph this normal probability distribution? Well, like any distribution, we're going to start with a horizontal line, and then we're going to sketch in the curve. Again, symmetrical and bell-shaped, or as symmetrical and bell-shaped as you can happen to get it. And it says it is symmetrical about the mean mu. So the symmetrical means that mu is in the center. So that's not precisely the center, but let's assume. Okay, so that would be where we have that length of 15 centimeters. And I'm going to label the axis so we know what that's talking about. And then it says the standard deviation is 3 centimeters. So if you go 3 different lengths to the right, kind of space them out evenly, and also 3 to the left, every one of those marks represents a standard deviation. Okay, so starting at 15 centimeters and going to the right, one standard deviation, which is 3 centimeters, the length of a bolt there would be 18 centimeters. Going another standard deviation to the right, so to the next mark on the page, that would be 21 centimeters. And moving to the right again, that would be 24 centimeters. And then similarly, moving to the left, starting at 15 and going down a standard deviation, that would be 12 centimeters in length, then 9, and then 6. Okay. All right. What percentage of the area lies under the entire curve? Well, this curve, although it never officially touches down and comes to a stop, it gets really so close that basically there's no area under there. And so hopefully it makes sense that 100% of the area lies under the curve. There's not like some area that has escaped and gone anywhere else. Okay, so 100% of the area lies under the curve. The next question, what percentage of the area under the curve lies to the right of 15 centimeters? Well, if 100% is under the curve and 15 centimeters is the mean, and so we're symmetrical about that, that 15 has to be right smack dab in the center, which means that 50% of the area lies to the right of the curve. Okay. And so then D, what is the probability a bolt chosen at random is longer than 15 centimeters? So in other words, what is the probability that some bolt that we happen to pick, okay, happens to come from this region somewhere in here? Well, that probability would be 50%. But remember, we write probabilities as a number between 0 and 1. Okay, and so for us, 50% would be written as 0.5 or 0.50.